Welcome to the IAM2 lecture. This is going to be covering the function domain range lecture PowerPoint. The learning target is for you to understand the domain and range of a function. There are three success criteria. 1. I can write an inequality, set notation, and an interval notation. 2. I can find the domain of a function. And 3. I can find the range of a function. We'll start off by reviewing a 7th grade core concept. This is how your note should be set up. We're going to review a 7th grade core concept. Given an inequality, you should see the picture here. Okay. We can look at the picture. The closed dot means it's a solid dot. It's a closed dot, meaning to include that number. So here, at -3, it's a solid dot. The fact that it's solid, we are going to include the -3. If it's open, like in this case, open, this tells us to not include. Let's look at the 2. It's solid. So this is to also include. And this is solid. So we are also going to include. This is the format of writing an inequality. You're going to start with the letter. And to the left of it is going to be the smallest number. Then to the right of it, you're going to use one of these two symbols. It's going to be the largest number. Okay. If it's this symbol, this means to. This doesn't include it because there's no equal sign. So this is going to be open. Okay. This is did not include. This one is open. Not include. But if it has the equal to symbol, which is the bar on the bottom, this means it's going to be close. That means to include. Likewise here, this is going to be close. This means to include that number. So here's an example. In this problem, you can read this as saying x is greater than -2 because it is greater than that small number, -2. Here, this should be a +7. +7. You would say that x is less than or equal to +7. Okay? Because it is less than the larger number. So here, this is the way we do it. We start with the letter, so x in this case. Then we pick this number, which is the smallest number, which is -3. And then it's the include because it is solid. So we pick the include one. So we close that. So we draw this symbol. And this is 2, which is the larger number. So we pick one of these two symbols. And the two symbols here are, it's going to be including. So we use this one. If you look at the second one, we start by writing our x. The smallest letter is the -3. Do we include it or do we not include it? We do not include it. So it's open. So it's this symbol. And then the 2, which is are we going to include that or not include that? We are going to include that. So we put the bar under it. Okay. The way you would read this is that you would say for number 1, you would say x is greater than or equal to -3 and x is less than or equal to 2. For this one, you would say x is greater than -3 and x is less than or equal to 2. Let's make sure you understand this core concept check by writing the inequality. This is the format. Do it here. For the first one, let's take a look. It's closed here. So we are going to include 2. Then it goes all, and what's the smallest number? -4? No. Is it -5? No. Is it -6? No. It goes on forever. It goes all the way to negative infinity. And the fact that it goes on until negative infinity, you can't close it. It is going to be open at negative infinity. So the inequality that you can write here is start with x, and the smallest number is negative infinity, and we're going to open it. So make sure we keep it open right here. That's the open. And then it's going to be closed at 2. So we put this symbol, close it at 2. This means x is greater than negative infinity, and x is less than or equal to 2. You might see it like this. There is a negative right here. Sometimes you actually don't see the negative infinity. You're gonna see it like this. You're gonna see it sometimes here. You're gonna see it without the negative infinity. Let's do the second one. So 2, we open it at 2. This means to not include the 2. So we write x, and we saw that the smallest number is 2, and we're going to not include it. So it is this symbol, not include. So it's this symbol. Then it goes all the way into what? Infinity. Okay. It goes all the way to positive infinity. Do you want to write positive infinity? No. Just write infinity. And here, it's going to be this symbol because it's going to be open here. Normally, they don't ever write this like this way. You're going to see it like this, 2 less than x. So you might see it like this without the infinity. But you never see it like this. You're going to see the letter goes first. So you're going to see it flip. So you're going to see it as 2. You're going to see the letter first, always. So you're going to see it as x is greater than 2. So do you see how it's just flipped? Let's see how the answer looks like. Okay. So notice this is written without. This is written without the infinity. And you see how the x goes first, so they flip the symbol. So this is how you write the inequality. Let's look at set notation. We have our inequalities given. So set notation comes from the inequality. So you start with the inequality. You see that in blue. Then you're going to put the fancy bracket. The fancy bracket means the set of, or the list. In other words, this is the list of. And the set notation starts with the letter. So it's the set of all x. Then you have the bar such that, then the inequality. So in this case, it would be the set of all x such that x is greater than or equal to -3, which is less than or equal to 2. The next way, same thing. It's the fancy bracket, so it would be the set of all x values such that x is greater than -3, which is but less than or equal to 2. This is how you write it in set builder notation. You just put the inequality in between the set, writing the variable and the bar. You're going to see it like this. The first one, you write the set of all x such that x is less than or equal to 2. The next one, the set of all x such that x is greater than 2. That's how you write it in set builder notation. This year, we're not going to be covering a lot of set builder notation. What you have to understand is interval notation. You're going to see this a lot. Interval notation. This is when you put it in an interval or a bracket. So the small number is on the left-hand side and the large number is on the right-hand side. And the symbols that you put are this way. If you include, they call this a bracket and they call this close. So they call this the close bracket. If it's to not include that, they call this the parentheses, and they call this open parentheses. Right? The other one is also the same thing. That's parentheses, and that is open. But if it's a bracket here, this is bracket. Mind my spelling. And this is when it's closed. So let's take a look here at this symbol. The smallest number is -3. And at -3, do you see here? It says it's closed. Right? That's this symbol here, close. So it's a closed bracket. You put the comma. And here it says this means also close at 2. So 2, close it at 2. Next one. Do you see how this symbol means open? So the -3 here is going to be open. And here, comma 2, this symbol means it's closed. So it's a bar here. So that's how it should look like in interval notation. Let's look at this one. Please understand that the inequalities look a little bit different. So these inequality, remember, it was this goes all the way to negative infinity. So it should have looked something like negative infinity less than x. X is this symbol, then it's this symbol at 2. So you might have seen it like that. And this one was 2, this symbol here, which is open, x, and I think we open at positive infinity. Okay. The reason why you should write it like this is because this is how you translate it to interval notation. So this negative infinity was the smallest, and we opened it. Right? Do you see how this is open? And then the larger number was 2. We closed it at the number 2. Here it was open on 2. And this is infinity, so it's also going to be open at infinity. There you go. So this is how you write that notation. So looking at the inequality, you could determine if it's an open parentheses or a closed bracket. Our main vocab. So before this finishes up how to write it in inequality, how to write it in set notation, and how to write it in interval notation. So that is your first success criteria. The next is the vocab. The domain of a function is the set of all possible input values. So this is if you look at it from left to right. Let me change this in blue for you. This is what happens when you look at it left to right. Left, look, left to right. So if we take a look at this picture, the domain is left to right here. And this value in terms of x, so these are your x values. We saw that it goes all the way here. And it stops here. And it goes to the left. And this is what it looks like all the way to the right. The value here in terms of your x is negative 1, negative 2, negative 3, negative 3. And this is the value 3. So if you write the inequality, it should look like that, right? It is closed here at the negative 3, and it is closed here at the 3. Let's look at the range. The range of a function is the set of all possible outputs, or here it is the y values. The y values that you have are your range goes all the way above here. So this is at the value 2, goes all the way down here to the negative 2. And remember, they're closed both at the 2. So if you write the inequality, it looks like that. Y, and it's closed on both sides between the negative 2 and the 2. So that is how you write the domain and range. So let's look at an example problem. You're going to write the domain, range, and inequality in set notation, in inequality, in set notation, and in interval notation. So let's start doing the first one. Let's look at the domain. The domain here goes from 1 to 3. So the domain would be x. It's open on 1 and it's open on 3. For the y, it looks like that. That is your y value. The smallest value is 2, and it goes up the way to 4, and it's open. Okay, that's how the inequality will look like. We can now put it into the set notation by putting the fancy bracket. And in interval notation, we saw that it is open at 1, open parentheses at 1, comma, open parentheses at 3. For the range, it's open at 2, and it's open parentheses at 4. Now, if you look at number 2, you would say that the domain here is closed at 1, and it's closed at 3. That's why they use these symbols. Okay. This just means it's closed. Do you see the extra bar down here? It's closed. It's closed at 1. It's closed at 3. Here it was open. Open. This is close. Close. Because it includes those values. Then the range, it's open. It's closed. So this should be closed. Let me make this in red. It is closed at 2 because you see it's closed at 2, and it's closed at 4. So it's closed at 2 and it's closed at 4. Set notation, just put it in the fancy bracket. And in interval notation, it is closed on both sides. So you use the closed brackets on both sides. Okay. Next part. Now you're going to explain the domain and range of this polynomial. This is what you're going to be doing a lot. The range is the set of all possible x values. So that is, you're looking at it from left to right. Looking at it from left to right, you would see that it is a arrow. Do you see how it's an arrow pointing to both sides? So it is an arrow pointing. So this is an arrow. Arrow. So it goes on forever. It goes all the way to negative infinity, and the other way it goes to infinity, positive infinity. So you would say that the domain exists open at negative infinity and open at positive infinity. In other words, you could call this all real numbers. The y, so that's how it looks like in the 3 forms. The range is the set of all y values. That is in red. And we saw here that these are your range. Goes up and down. So this is how it looks like. Please understand here, it stops, right? It stops right here. It stops at the 4. So here it stops, or it closes at the 4. So this is why it's a circle here. It closes it here. And this is the arrow. It goes all the way to what? Positive infinity. So the range should be, oh, sorry, this is not -4. This should be -6. Yeah, -6. So this is -2, -4, -6. It went by 2's. So here, y, and the smallest value is -6, and we close it. It includes -6. And then here, it's open at infinity. This is how this should look like in inequality, set notation, and in interval notation. The hard bracket here just indicates that it's closed at -6. All right. Here's how the core concept looks like. And those are all the notes that you need for the domain and range of a polynomial.